In this video, we are going to work example 1.5. Example 1.5 states, I begin at rest and walk around a 400-meter oval track, stopping 5 minutes and 20 seconds later at the same place I started after circling the track once. In part A, you're supposed to find the average velocity during this time, and in part B, you're supposed to find the average speed during this time. So we're supposed to find velocity and speed, which sound like the same term, but they're really not. Velocity is a vector term. It's displacement divided by time. So velocity is equal to displacement over time. And speed is a scalar quantity where we're not going to consider direction at all like we would with velocity. And that's just going to be the distance traveled over time. Now for both parts of the problem, the time is the same. The time, delta t, is equal to 5 minutes and 20 seconds. So if there's 60 seconds in a minute, what we're talking about here is 320 seconds. So I'm going to go ahead and convert that into seconds. It's going to help us out later on. In part A, you're asked to find the velocity. So here's part A, and again, we want to find the displacement over time. But if you consider what happens here, if you walk around a 400-meter track and you come back to the exact same place that you started, your displacement from where you were at the start is actually equal to 0. So it sounds strange to say you might have really exerted yourself in walking around the track, but you actually haven't gotten anywhere from the start to the finish. So because the displacement is 0, the average velocity must also be 0. In part B, though, your distance traveled is not 0. In part B, the distance that you traveled is the distance that you walked around the track. So the distance that you covered, because it's a 400-meter track, is 400 meters. And the average speed, I'll use v here for speed, the average speed is going to be given by 400 meters, the distance, divided by the time, which is 320 seconds. Or 400 divided by 320 is going to be 1.25, and the answer should come out in meters per second. And what we found here, again, just to clarify, this is the average speed, not the average velocity. And that is how you solve example 1.5.